So in this video, we're going to talk about scatter plots more closely. So first, the idea of a scatter plot means we're going to be plotting our x and y, our response and explanatory variable, on a graph. So just as a reminder, x goes along the horizontal axis and y goes along the vertical axis. So that's what our plots will look like. Once I have this plot, there's going to be certain questions that I want to ask. So the first question I want to look at, or sort of ask myself, which might seem a little strange at first, is if the graph seems straight enough. You previously were mentioned the idea of a linear relationship. So this is what we're talking about. Does the relationship seem to be a straight line? And we're talking about something being straight enough. I'm really going to be looking for lack of a curve. So if something does not seem curved, I'm going to say it's a linear relationship. And then if it is straight enough, I'm then going to ask myself the follow-up question, is if the relationship is a positive or a negative relationship. And this goes back to the idea of slope that you learned in algebra class, and we'll look at some examples here in a moment. The second question we're going to ask is how strong the relationship is. And this is going to be looking for how tight or how close the points are together. And then finally, the last question that we're going to ask ourselves is if we just happen to see anything unusual. So we're going to look at these three questions more specifically with some graphs here. All right, so with our first idea of looking for a linear pattern, the idea of it being straight enough, and the direction. This first graph I have labeled as a positive linear relationship. Now first, let's talk about the linear part. So if I look at this pattern, not all the points fall exactly on a line together, and that's how real data is going to be. Things aren't going to perfectly fall on a line. There's going to be this scattering. That's why it's called a scatter plot. And so when I look at this graph, when I look at the relationship, if I were to put some type of straight line relationship between these points, would you feel this horrible need to bend that line? I would say probably not. In fact, it maybe feels like this is a pretty good pattern there for me. And then I'm saying it's a positive relationship because I have that positive slope. Let's remind ourselves, though, what a positive slope means. It means as x gets bigger, or I move to the right here, y also gets bigger or moves up. More specifically, I know it's a little hard to read the variables here. This is the height of someone in inches, and this is their hand span, so how big of a gap it is between their thumb and their pinky finger. So as someone gets taller, that's us moving to the right, we are seeing a pattern that their hand span is also wider. And that probably makes sense to us that the taller the person, sort of the bigger the hands and the bigger that hand span would be. Now if we move over to this negative linear one. So here I'm saying it's negative linear. So again, straight line, if I were to put a line through it, do I feel this horrible need to bend that line? Not really. So I can feel pretty good about putting a straight line on this graph, but this time the relationship looks to have this negative slope. And again, what a negative slope is, as a reminder, as x gets bigger, or we move to the right, our y is actually moving down or getting smaller. So here, as someone got older, this distance tends to get smaller. Now this last graph is an important one for us to talk about because I'm saying there's no linear association. This comes back to that very first question. If I were to try to put a straight line through this graph, would you feel the horrible need to bend it? Why, yes, I would, right? There seems to be this curved pattern going on with this graph. So there's not a linear relationship. So what that means for us in this class is we're not going to worry about plots that look like that. But what I want to point out is other classes would worry about this plot. Now, why would they? There is definitely a pattern going on between X and Y. It's just not a straight line pattern. And in our class, we're only going to look at those that are straight line patterns. This is a little bit more complex of a pattern for us to look at. So this would still be one of interest, just not for our class. All right, next let's talk about strength. And I've sort of given some two big extremes here to talk about the strength when looking at a plot. This one I'm calling a strong association, this one I'm calling weak. But let's actually first go through and answer the questions we answered up here. Would you feel good about this being a straight line relationship? Yeah. Would it be positive or negative? Will it be positive as we move to the right? We're also going up. And it's actually the two handspans, the right handspan and the left handspan, that we're looking at here. Now when I'm talking about strength, I'm then sort of looking at how close those points are to that line. And again, they're not all on that line that I would put through here, but they're all pretty close to that pattern that we're seeing there. So the tightness there is a strong relationship. Versus over here, I mean, if I were to ask that first question of straight enough, well, I don't really see anything curved, so I suppose I would say yes. But what about the positive or negative relationship? Well, I mean, there really doesn't seem to be one, right? I mean, kind of my straight line would pretty much look this way. And that doesn't even really have a slope. That's what a zero slope would look like when I have this horizontal line across here. So here there's a weak relationship, so weak in fact that I can't actually even see a pattern. Now first, just note here that a plot is not the only place that we're going to talk about strength here. Looking ahead, correlation is also going to give us strength. It's going to give us an objective number to measure strength, versus right now us just looking at a plot to get a very subjective idea of how strong the relationship is. All right, last thing that we want to look at in a plot is if there's anything unusual. So I'm actually going to start with the one on the right because this is probably the one that students are more able to see. It's what's called outliers. So if I looked at this graph, there might seem to be some points that seem to stand out kind of away from the rest. So there's this one over here that's kind of all by itself. And there's kind of those two up there that just really don't seem to fit the pattern of the rest of the data. Now what I would do with those outliers is first actually check to make sure I didn't misenter the values. So I have this really tall person over here with a very short foot length. Can someone that tall have a shorter foot or a smaller foot? Yes, but I would just want to make sure that I enter those values correctly. And this would be someone who is much shorter but has a very long or bigger foot. So I would just want to check to make sure that I enter those values correctly. So that's one of the first reasons we look for outliers. Then we might want to look to make sure they are part of our population. So for example, if I was only looking at adults and these two happen to be children or something, for example, then that would give me a reason to remove those values from my data set if they're not part of my population. But if these numbers were correct, I entered them correctly, they are part of my population. For our sake right now, we would leave them in because I don't have a good reason to remove them. Now shifting over here on the right, onto the left here, I have a plot that is actually color-coded that I know you might not be able to see on mine. Great, but hopefully you can see on your handout a little bit better. Here we're looking at the height of someone in their handspans, and notice this is actually the exact same graph from up here. All I've done is sort of color-coded and given different icons. So a blue circle is a male, and the red plus is a female. And so you sort of see this separation that most of the red tend to be down here, and most of the blue tend to be up here. So gender is sort of explaining things here as well. So that might just be something else we would want to take into account and look at the two genders separately, for example. Now, while we're talking about scatter plots, let me also show you how to get a scatter plot in Statcrunch. The first thing you would want to do is just go to the home page here. Is to kind of load your data set. So like I selected a file on my computer, or you can just click on the data set in a Statcrunch group, for example. So get the data set you want. And then once I have my data set loaded, I'm just going to go to Graph, and there's the scatter plot option. And then for X here, I'm just going to use the number of fat grams in a serving of ice cream versus its calories. And here's sort of what the scatter plot would look like. To get like the grouping graph I had for the males versus females, I'm grouping by a categorical variable here. For here, for example, I'm going to use type, because all the blues here are kind of what's like low fat or light ice cream, and all the reds are regular types of ice cream. So the kind of where you kind of see a very strong separation between those two groups there as well. So that's looking at scatter plots and how to create them. We'll start looking at some examples in that next video.